Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm extremely happy about this and I'm very glad that I was able to come up with my own solution to this question without any help. So let's go over it and let me show you how I did it. So this is 1625 lexicographically smallest string after applying operations. So basically, you're given this string has an even length, only numeric, and two integers a and b, and you want to basically apply any of these two operations as many times as you can to find the alphabetically lexicographically smallest string that you can get, either rotating to the right by b positions or adding a to the zeroth indexes to the odd indexes of the value and then cycling it back. So if it's bigger than 9, just set it, for example, if you have 12, then set it back to 2. So, yep, let's go ahead and do that, basically. So what this means is cycle it back until it's not bigger than 9. So take the rightmost digit. So, yeah, let's go ahead and make a set called scene, and let's have a queue called S. Because we're trying to find the lexicographically smallest and we have a string, it's going to sort it by alphabetical order as we heapify the queue. So while queue is not empty, let's run this BFS and greedily take the smallest one we can get. Let's call this current. And so we're starting with 5525. So basically what we're going to do is either add or rotate. To rotate to the right by b places, you'd get 2555, and then, or you can just add, so you get 5, 4, because 5 plus 9 is 14, and then 2, and then 4 again. So this one's smaller, so we're going to go with this one, and we're going to push that onto the queue and try that path. From there, again, we're going to add or rotate to the right. So we're just going to keep doing that basically. Okay, so let's make two deep copies of current because we're going to want to either rotate or add to the odd indexes, right? So at any point, if the current is in scene, then we can continue, and we're going to try to store a string in this set, because you can't just store an entire list in a set, and we have to update and keep track of the state. Cool. So now let's just say that 1 is used for adding and 2 is used for rotating. So 2.rotate b. So rotate to the right by b places. This is a built-in function. That's why I turned it into a doubly ended linked list. And then for I in range length 1, again, if the index is odd, then basically this is a string, right? So we're going to call this new value is an int of the current value, and we want to add a to that, right? And then if the new value is bigger than 9, then we're going to set it to an int of, again, we're trying to extract the last value, so we have to turn it back into a string and get the -1, which is the rightmost character, and then we're going to do that, right? And then we're just going to set the current index to a string of new value. Cool. So at each point, we're just going to heap push onto our queue, join of 1, and join of 2, right? Because these are strings, right? That's why we did all this casting. So let's go ahead and print our current. Okay, perfect. You can see 2050 is the smallest rotation we can get, and ending the BFS by not visiting the same thing twice because we're going to make the best, the most obvious greedy choice at each step. So, and then at the end, we can just add everything to a sorted list, this string of numbers, to get the smallest one at the very left of the sorted list. So at the end, we can just return SL of -1. Giving us 2050 here and 24 here. Okay, let's run it. Okay, that's not correct. It looks something is wrong here. So let's go ahead and add this right here instead. So it's still incorrect. So let's print our current. And it looks like, let's print 1 and 2. So something looks a little bit incorrect. So we just had the whatever we needed. Again, if we're adding it, if it's bigger than 9, then do this. So, okay. So let's go ahead and actually, yeah, let's see 1 and 2 here. Oh, we're going to add afterwards, right? Not before. So 2050, yep. We're going to add join of cur. Let's do a deep copy because that's probably going to mess up the results. Okay, that's still not correct for some reason. If we print cur again, you can see that eventually we do get what we need. So let's print SL here. Yep, 2000. Oh, that was my mistake. We're returning the rightmost, the biggest, instead of the smallest, as it says right there, the smallest, right? Okay, let's submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for question 1625. This is a BFS medium level question.